Hello everybody, this is Mrs. Snook with section 6.7, which is on coordinate geometry. And what we're going to do is we're going to classify shapes in the coordinate plane. And we're going to use certain properties that are going to help us classify these shapes. For example, we know that these are parallelograms, so we should have some parallel sides. We know that in squares and rectangles, you have 90-degree angles, so therefore there should be some perpendicular sides. We know that angles get bisected, and we also know that some sides are going to be congruent. And so to find these properties, there's actually some formulas that we can use. For example, to determine if sides are parallel or perpendicular, you're going to use the slope. To determine if you have something bisected, okay, you can use the midpoint, because that will tell you exactly where that bisection should happen. So let's see. Midpoint of the x is x1 plus x2 over 2, and the midpoint of the y is y1 plus y2 over 2. And then to confirm that sides are congruent, you're going to use the distance formula, which is d equals, put in a big square root, x2 minus x1 squared plus y2 minus y1 squared. Okay, so we're going to have to know these formulas and use them today. So the first thing we're going to do is we're going to have a quad, so a quadrilateral four-sided figure called SPAT. And it has vertices at S is at 1, 3, P is at 4, 4, A is at 3, 1, and T is 0, 0. So the first thing I'm going to do is just draw a sketch so I can get this pictured in my mind. So let's pause here while I draw my sketch. All right, so I've drawn a quick sketch of what this shape looks like. Here at the origin is point T. Here is S, P, and A. So now the first thing it says for me to do is to find the slopes of each side and justify why SPAT is a parallelogram. So I'm going to get the slope of line segment TS, and I'm going to compare that to the slope of line segment AP. So I'm just going to use my slope formula, y2 minus y1 over x2 minus x1. So from T to S, I have a 0 minus 3 over 0 minus 1, which gives me 3. And now let's look at AP from A to P. So from A to P, I have a 1 minus 4 over 3 minus 4, which gives me a negative 3 over negative 1, which is also 3. So therefore, I can say that AP and TS are parallel. Now I got to check the other two sides, because in a parallelogram, both opposite sides are parallel. So now I got to look at AT and PS. So slope of AT is going to equal 0 minus 1 over 0 minus 3. So I get 1/3. And then the slope of PS is going to equal 4 minus 3 over 4 minus 1. And I get a 1 over 3. So therefore, AT is parallel to PS. And since I've got opposite sides parallel, I have a parallelogram. Now we're going to find the slope and length of each diagonal and to classify that parallelogram as a rectangle, a rhombus, or a square, and we're going to give the justification. So looking at our picture, I would have a diagonal going between A and S. So I'm going to use line segment AS. And I also have a diagonal going from T and P. And so then over here, line segment TP. And I'm just going to make myself some room. First thing I'm going to do is get the slope. So the slope of AS equals, let's see, 1 minus 3 over 3 minus 1. So 1 minus 3 over 3 minus 1. So I get a negative 2 over 2 equals negative 1. And now the length of AS, I'm just going to call this d sub AS, it's going to equal, I'm going to put a big square root, parentheses, parentheses squared, plus, parentheses, parentheses squared, minus, minus. And then remember, just make sure you subtract the y coordinates from the y and the x from the x. So from A to S, the y's are 3 and 1. So 3 minus 1 squared. And the x's are 1 and 3. And what's really nice about this is it doesn't really matter which way you go, because when you square these, your answers were all going to be positive anyways. So I get the distance between A and S is going to be 2 squared plus 2 squared, square root of that. I get square root of 8, and I'm going to reduce that as 2 root 2. All right, now for TP, let's get the slope of TP. So let's do y minus y over x minus x, so 0 minus 4 over 0 minus 4. So my slopes are matching, and then, that's weird, positive 1. And then the distance between T and P. And I always set up my formula like this, put in a big square root, parentheses, parentheses squared, plus, parentheses, parentheses squared, and then 2 minuses in here. So y minus y. So 0 minus 4, and then is here. And then x minus x is also 0 minus 4. So I'm going to get a square root of 16 plus 16 is going to be square root of 32. So your distance is going to be 4 square root of 2. So notice those diagonals are not congruent. So this is not a rectangle. I do have perpendicular because the slope MAS is -1 and MTP is +1. So if I do a flip and switch, that works. So I have line segment AS is perpendicular to line segment TP. Line segment AS is not congruent to line segment TP. So I don't have a rectangle, but I do have a rhombus. And my justification is going to be quadrilateral with perpendicular diagonals implies rhombus. All right, next one. We have quadrilateral wind with those vertices located. Find the midpoints of each diagonal and use that to justify why wind is a parallelogram. Okay, So we're going to have a diagonal from W to N and another diagonal from I to D. And the reason I know this is when we name the quadrilaterals, we go in order. So W is a diagonal with N and I is a diagonal with D. So I'm going to find the midpoint of WN first. So the x-coordinate of that midpoint is going to be x1 plus x2 over 2. So negative 14 plus 3 over 2. I get negative 11 over 2. And then my y-coordinate is going to be y1 plus y2 over 2. y1 is 4. y2 is negative 9 over 2. I get a negative 5 over 2. So the midpoint of line segment WN is negative 11 over 2, negative 5 over 2. Now I'm going to find the midpoint of ID. So line segment ID. The midpoint there is, let's do x1 plus x2, so 1 plus a negative 12. Over 2 equals negative 11 over 2. And the y-coordinate of the midpoint, let's do y1 plus y2 over 2, 6, and negative 11. Gives me negative 5 over 2. So I have negative 11 over 2, negative 5 over 2. So what this means is that those two diagonals bisected each other because the midpoint of each diagonal is in the same place. So that means I have a parallelogram. Now it says find the slope and length of each diagonal. Classify as a parallelogram, rectangle, rhombus, or square. So first I'm going to do line segment WN. And I'm going to get my slope. So slope of WN. So W and N. So y minus y1 over x minus x1. 3 minus a negative 14. I get a negative 13 over 17 for the slope of WN. Let's get the length. I'm going to pause here and fill in my numbers. Okay, so I have the slope of one diagonal as negative 13 over 17, and then I have its length as square root of 458. And I'm not going to convert to a decimal. I'm just going to leave it like this. Now I'm going to calculate the slope and the length of line segment ID. So slope of ID is going to equal, let's do y minus y, so negative 11 minus 6 over negative 12 minus 1. And I get negative 17 over negative 13, which equals 17 over 13. So compare, and I do have a flip and switch. So I know these diagonals are perpendicular. So I have a rhombus or a square. And then the next one is the length of our diagonals. And I'm going to go ahead and pause here and fill in my numbers. All right, so my length of ID is also 458. So that means that my diagonals are congruent. So I could have a rectangle. And my diagonals are perpendicular. So I can have a rhombus, which means this is a square. So just as a reminder, if your diagonals are congruent, you have a rectangle. If your diagonals are perpendicular, you have a rhombus. And if it's both, you've got a square. All right, the last one we're going to do is we're going to graph the points of this triangle, and we're going to label it, and we're going to figure out the most precise name for this triangle. So I'm going to pause right here while I plot my points. All right, so I have plotted my triangle, and what I'm going to do is start figuring out slopes and lengths. First of all, let's get the length between B and H. Big square root. So -2 minus 4. I'm doing the y's. Now I'm going to do the x. 1 minus the -1. So that's going to give me the square root of -6 squared plus 2 squared. Okay. Now let's get the length of BF. And then just plug in your coordinates. So 6 minus 4, I did the y's, now I'm going to do the x's. 5 minus -1, which is a 5 plus 1. So I get the square root of 2 squared plus 6 squared. It's the same thing, so I get the square root of 40. So right now, I know that BH and BF are congruent with each other. So at the very least, I have an isosceles triangle. Let's also take a look at slope. I want to see if we're perpendicular because maybe we have a right angle in there. Okay, so the slope of BF is 4, let's do 4 minus 6 over -1 minus 5. I get a -2 over -6, so I get a 1/3. And then the slope of BH -2 minus 4 over 1 minus a -1, which is the same thing as 1 plus 1. So I get a -6 over 2. I get a -3. Lo and behold, we have a right angle in there. So this is an isosceles right triangle. It's not letting me write. Now you may be asking yourself, I didn't do the length of FH. How do I know that FH isn't congruent? How do I know I don't have an equilateral triangle? And the reason is, once I knew I had a 90-degree angle, it can't be equilateral because those would be 60, 60, 60 in their angles. This one, because it's isosceles, this is going to be a 45, 45, 90 triangle. And that's a triangle that we're going to work a lot with when we get into Chapter 8. So that's all for today's video. Thank you for watching and have a great day.